Hi guys, and thanks for dropping in. I spent the last Friday night playing with this piece of software, Backgammon, for the ZX Spectrum, and I thought I should make a video about this, not about the specific version of it, but rather for the game, the algorithm, how challenging this might be for the programmer who tries to put all the bits together for the algorithm and cover all possible moves from every position and so on and so forth. So it's an interesting algorithm always behind the scenes that does the calculation, and then the moves are depicted on the screen, and the moves are decided upon the results of this algorithm. And the only random thing might be the dice. That's another thing to put in the equation. There are many typical algorithms used for implementing computer programs, intelligent computer games, from simple intelligent moves like tic-tac-toe to backgammon and chess. And since these games do require some thinking, the outcome always depends on a combination of the player skills and chances, elements like the dice or other. And for this purpose, a random number generator can be used within the algorithm to produce the random numbers that we need. Now, I really don't know which algorithm has been used in this case for the ZX backgammon. I'm guessing the random number generator has been used for the dice, but if you think of it like this game, it was written back in 1983. It is really impressive how they managed to put everything together in 16K package, so that this can run on 48K Spectrum and 16K Spectrum, the very first ones that reached the markets. And it feels like really exciting for me to trying to understand how the algorithm works and to deal with games, but not dummy games, but intelligent games. And at this point I think I'm going to lose this game. So I have created a special playlist within the channel so that we can start with this video and then analyze, or try at least to analyze, how intelligent software works in the games industry, because games is not always about shooting around. And just to get an idea of how complex this might be, I'm going to put some links here down below in the comment section, so for you to follow those links and check some algorithm analysis from the brains behind the gaming industry, as all the intelligent games implemented are demanding and require some deep analysis prior to implementation. And for example, an algorithm that might be used for the backgammon is the MiniMax algorithm, which is a generalization of the alpha-beta search. Just to give you an idea, and for more information please look at the links down here below. I was so close, that close, but I've lost the first game, so Spectrum has the lead now. This software has an option for the skill level. It's either easy, medium or hard. I picked the easy one, and I also picked the option not to throw my own dices for two reasons. Because I cannot throw my own dices. It's either way, Spectrum will do this for me. The random number generator will work in the background, but also because I wanted to have an excuse if I'm going to lose by the end of the game. And at this point we can make an assumption. If I have picked the medium skill level or the hard level, then something would be more difficult for me, and even more difficult for me that could be based upon the results of the dice thrown. Another interesting point is that Spectrum is fast, like the thinking behind the whatever move needs to do is fast. Uh, it's waiting for my moves, and then it can calculate its moves after the dice is thrown very quickly. So let's make another assumption here. It's pure machine language behind the scenes, along with some um, basic but just the uh, simple parts of the game, and it couldn't be any other way because this can be intelligent, can be fast, and can be put in the 16K of RAM. Just 16 kilobytes of RAM available, so the programmer didn't have this luxury of getting more RAM and do more fancy stuff around the game because they didn't need to. It's just basics, a basic algorithm, and a pretty much fancy presentation, and that would be all. And nowadays probably they would do that using Java and a big amount of RAM and huge amount of RAM actually, and other tools like neural networks, calculations and algorithms based on neural networks and other fancy stuff. But back then it was just as hard as it gets to put everything together in a nice pack with just 16 kilobytes of RAM available. There is also another procedure which foresees to the end of the game, and so it can offer you a double game, which you can accept, and you can lose the current game by 1 point, or you can of course ignore the offer. But then if you lose the game, then it's going to be doubled. Now, wrapping up for the day, this is the first video out of hopefully a series of videos for games and algorithms, and how algorithms can be used in order to implement intelligent games that of course do require user interaction and skills. You can find this new playlist within the channel, which is named Algorithms and Games, and hopefully we should have the chance to analyze, or at least try to analyze and explain how these games are based on algorithms, and how the programmers managed to implement those games, which were the challenges and all the tricky parts they had to overcome. So if you like this stuff, please give us a thumbs up and do consider subscribing, and I'll be catching you soon with another video. It's going to be either hardware review, presentation, demo, repair, fix, modification or something, or it might be algorithms and software like this present video. In any case, I'm looking forward to seeing you online, and thank you so much for watching. If you have any ideas or comments or something that you're looking for, and I can help, I'll be more than happy to help. Just leave your comments in the comment section down here below. You know the drill. And so until next time, you take care. Thank you so much for watching. Bye for now.